I work for Hastexo, and unfortunately my co-speaker couldn't make it today, so it's just me, right? So forgive me if talk's not as good as it would have been, but I'll do my best. This is my Twitter handle, and this is our company's Twitter handle as well. Feel free to drop a note if you feel like it. We have these exact slides up on GitHub pages. So if you want to follow along, if you can't see or right now, or if you want to look at them later, just point your browsers to hastexo.github.io/OpenEdX2015. Right? It's exactly what I'm going to show here, sans the little pieces of demo. Okay? So without further ado, this is OpenStack for OpenEdX inside and out. What is this really about then? What made us decide to use edX and OpenStack? The motivation was this. We are a consulting company, and we consult on OpenStack, and we also do a lot of training, right? So we fly out to places, do training, and we've discovered, as all trainers do, that training is time consuming, and we'd rather develop the course once and have trainees and students take it at their own pace, right? So, of course, edX came to mind as the MOOC of choice nowadays, or the MOOC platform of choice nowadays. The problem is, on our training environments, when we give trainings regularly, we give each and every student a training environment. In other words, if we're teaching OpenStack or if we're teaching Ceph, we give students a cluster to play with, their own cluster, so they can deploy things, break things, and then we go in and fix them, and so on and so forth. How could we achieve the same thing in a self-paced, massive online course, right? So this is the motivation. How do we do that and not bankrupt anybody at the same time, okay? I'm gonna assume a little bit of knowledge about OpenStack here, not too much. Okay, so I'm going to use a couple of terms that I'm not going to spend too much time to explain, right? So you're going to get the most out of this if you know a little OpenStack. You should know about edX configuration, or Ansible, okay? In other words, you should have probably deployed edX at least once so you can understand what I say when I mean playbooks and roles, okay? And you should probably have heard of Xblocks, right? Has anybody not heard of Xblocks here? Okay, cool. Okay, so you're going to be fine. Okay, so now why? Why did we choose OpenEdX? Why did we choose OpenStack? First off, why OpenEdX? Well, mostly, since we were from a background of open source and open source consulting, we wanted to build our training on open source platform. And of course, OpenEdX qualifies. Now, that's not the only thing. Being open source is not all it takes for an open source project to be good. It needs to be alive as well, right? There needs to be leadership that embraces the community and contributions, and that's also OpenEdX is top marks on that, thanks to, for instance, Singing Wolf Boy here in the front, Dave, or what's her real name again? DB. Yeah. Okay, so DB. Known as Singing Wolf Boy on IRC, and NetBat, also here in the room, which helped us a lot. So this is what we think is a good open source project, one that that has people behind it that talk to you. Okay, so OpenEdX, top marks on that. Community and openness. Technology. OpenEdX is built on Python, right? And Python is, it's basically just English that a computer can understand, right? So it's awesome that you can go in and read the code, okay? Because of PEP 8, right? Thanks to Guido, right? So the technology behind edX is grokkable. We can easily go in and understand it. So that's another point. The third and almost the most important point is extensibility. We knew that no LMS platform out there would do what we wanted out of the box. That's a given. So we wanted something that we could use to build on, okay? And, Xbox, right? That's what caught our attention, and that's why I'm here, really. And of course, the coolness factor, right? Open edX is cool. It's the cool kid on the block on LMS, right? So we wanted to work with something that we would be glad to be working with every day, and Open edX certainly qualifies. Why OpenStack? Well, openness and community, technology, extensibility, coolness factor. Do you see the pattern here? It's also an awesome open source project that has a great community around it. The technology, well, it's written in Python as well, so, right, awesome. It's extensible by definition, as all cloud platforms should be. You need to be able to build your own stuff in there, right? And it's also the latest, greatest, coolest kid on the block as far as cloud platforms go. So, bingo, OpenStack, Open edX. First problem we faced, deploying Open edX on OpenStack. Okay, so how do you go about doing that? If we're just deploying a single node, it's pretty easy, right? You take the sandbox.sh script in edX configuration, port it to cloud config, put it in a heat template, and then use the edX sandbox playbook to fire up a single node. Okay, so that's pretty easy to do, really, and it's very documented in the edX docs. Okay, so we didn't have a lot of trouble there, except with the fact that you do need 8 gigs of RAM to run a single VM, right? A 4 gig VM won't, you know, it'll crawl to its knees soon enough, and we took a while to discover that, okay? So that's easy. How about a cluster on OpenStack, right? That's the whole point. And, you know, I sat with what's your name again, sorry? Brandon. I sat with Brandon over lunch and we discussed clusters on OpenStack and otherwise, right? And we all had our little stories to tell, and doing clusters with anything really is not very easy. Luckily, edX is not all that hard either, okay? So we'll get to that in a moment. But the first question is, all right, so these guys, these edX guys, they have an edX.org site, right, with edX, and suppose with hundreds of courses in there, thousands of students, so they probably know what they're doing with edX, right? So how is OpenEdX deployed on edX.org? Luckily, last year, there was a talk by a guy named Fionil Patel. Is he here, by the way?
He is here today.
Is he in the room? That's too bad. I wanted to shake his hand, because that's sort of, that was our golden brick road to what to do about it. Okay, so he had a really nice slides with, if you're a medium installation, you do this, if you're bigger, you do that, so that was awesome. The only thing is, he didn't include any technical details on how to do it, right? As he shouldn't really. But anyway, we were still sort of in the dark as to exactly what to do, but we had a way to design a cluster. So now if you look, yeah, it's going to be hard, kind of hard to understand here, but bear with me. There's a user guy up here and an administrator guy here. So our cluster has a load balancer in front of an arbitrary number of app servers, right? Where an app server is composed of an LMS, the CMS, and everything that's not the Mongo data store or the MySQL store. Okay, so everything resides on a scalable number or an arbitrary number of app servers that talk to 3, or actually in our case, exactly 3 nodes. Okay, why 3? Because that's the minimum number of nodes for Galera. Okay, so Galera is, was our choice, of course, based on the fact that there's a nice MariaDB role in edX configuration, okay, for clustering MySQL. Oops, there you go. So we use that, and it requires at least 3 nodes to work. Okay, so that's why we have 3 backend servers here. All of the app servers talk to one of the nodes for now. It's an improvement to our cluster layer to have a load balancer between the 2. And the administrator, and this was key to how we did it, the administrator gets a deployment node in the cluster from which he runs the edX configuration roles and deploys everything to the rest. Okay, I'll get to how in a minute. Okay, so we have a design for a cluster. How do we implement it? Can we use examples from edX configuration? For instance, the AWS playbooks, or actually, it wasn't the playbooks, it was the cloud formation templates. Can we use those? No, because they were removed, right? And I talked to a couple of the guys here as to, okay, so why did you guys remove these templates? And the reason is nobody used them. All right, so, all right, fine. We'll have to come up with something from scratch. How about playbooks for clusters? We combed through edX configuration and we found something called Vagrant cluster YML, which is the sample cluster, I guess. Sample cluster playbook, I guess. And it gave us clues as to what to do about deploying this in a cluster. Okay, so that was awesome. Thanks to whoever wrote this. Is he or she in the room? No, he's not. Do you know who it is? Carson. Oh, Carson! Oh man, too bad. Yeah, I love Carson. He did a lot of things that we ended up using. Okay, so we have a playbook. What variables do we set then? So we went on a quest for finding the proper variables to set so that the cluster would work. Okay, so for backend nodes, you need to set Mongo clustered, Elasticsearch clustered, and MariaDB clustered equals yes. So awesome. Okay, that worked pretty well. There are a couple more. And for app servers, you need to point all of the database variables and backend variables to the database servers that you're deploying. Okay, so this is kind of hard to read here, but we pulled a little Ansible trick here, which is to say, always point for MySQL. If you're an app server, always look to the first backend server, whatever its IP address is. Okay, and for Mongo, you just say, use all of the backend servers that we have configured here. Okay, I'll get to how this works in a minute, and this is the end result of a dynamic inventory generator, okay, which OpenStack helps us with. All right. Next, we needed to write a heat template. Heat is the equivalent of Amazon's cloud formation, right? But it does basically the same thing. You write a sort of recipe for the deployment of a whole cluster, okay? In our case, we needed the following shopping list. One security group, one private network with a router, 2 cloud configs, a deploy node with an IP, a load balancer with an IP, 3 backend servers, and an arbitrary number of app servers. Okay, so this is all coded in a heat template. And you give this to OpenStack, and OpenStack will fire it up for you. Okay? It won't deploy edX for you, but it'll fire up the cluster, which is a nice step forward. Okay? And you can configure parameters to the heat template, such as, importantly, the number of app servers we want. Okay? And you get as an output the public IP addresses that were created. Okay? Next, the inventory generator I mentioned before. What is this? Well, we have an arbitrary number of app servers in the cluster, right? When I run Ansible from the deploy node, how do I know which ones they are? What are their IP addresses? How do I get this out of the OpenStack cloud? And we, from our OpenStack experience, we knew we can define something called metadata for a VM. So remember the deploy node I mentioned that the administrator can use? You can define as metadata for that VM the IP addresses of all the app servers, right? Which is very neat. So when the administrator logs into the deploy node, he can make an HTTP request to a fixed URL, and he gets what the app servers are. And this is awesome because I can then feed this into Ansible so that I just run Ansible playbook, OpenStack multi-node template, and it'll do its thing without me needing to know as a human what the app servers are. Okay? So this is actually the URL. It's fixed for any and all VMs in OpenStack. Okay? If you request this information from any VM in OpenStack, you get metadata. right? It's generic, sorry, generic metadata, but in the heat template, I can tell it to include information about the rest of the cluster, okay? Let's see how that works. Sorry about this, it's gonna be a little bit hard to read, but bear with me. Okay, so first things first. This is a fork of the edX configuration repo on the Cypress named release. Okay, this is up on GitHub. It's public. You can go in and use this if you like. To fire up a stack on OpenStack. Whoops. Sorry. You run a command such as this one. So let's see. Heat stack create, the path to the heat template, which we have put up in that edX configuration fork, and a couple of parameters specific to the public cloud we are using. So I'm launching a heat stack or a set of VMs on a public OpenStack cloud. It's not ours. We pay for, you know, as you would pay Amazon for a VM or two, we pay these guys, right? So we have no involvement with them. And I'm gonna fire up a stack here with one app server. I can't even see it. There it is. App count equals 1, and key name equals my SSH key so I can log in later. Okay, so this is how you create a stack, enter. Of course, we don't have time to wait for this to finish, it takes a while. Okay, I'm just gonna show you what it looks like as it is created. Right, so my OpenEdX 2015 stack is being created. It takes about 5 minutes for the stack itself to come up. And then you can log in and run the Ansible playbooks. Since we don't have a lot of time, I'm gonna cheat a little and use the stack I already created before. Okay, fine with you? All right. So I'm SSHing into that stack I created earlier. And I'm going to issue that very HTTP requests I mentioned to you guys a little bit earlier. So once again, curl that address, and I'm piping the output to Python mjson so that we can understand what it says really. Okay. All right. So on this stack, can you see the meta item here? I can see a list of my app servers and my lists of backend servers. All right? How is this useful? Well, this is useful because I can write a little script in Python, or any language really, that outputs JSON in a certain format, and Ansible can then read this as a list of hosts to deploy to. Right? So, we created such a script, right? And it lives in Playbook's OpenStack on edX configuration. So if I run OpenStack inventory.py dash list, right? Yeah, there you go. I get a nice little list of app servers and backend servers on my cloud from the deploy node. Right? Cool. Do you take my word for it that if I run Ansible here, it'll work? Please do, because I already ran it. So yes, it does work. You simply run Ansible playbook, pointing the host, -i OpenStack inventory.py, and the OpenStack Ansible multi-node playbook that we have also put up there. Okay, and this will deploy the backend servers and the app servers, and you're done. That's it. You have an OpenStack. You have an edX installation. All right. That's one thing. How about, so we have a nice cluster with edX on it. How about if we want to teach clusters on that? Okay, so getting back to our initial motivation, remember, we want to give students each and every one of the students or trainees their own cluster to play with. Okay, we think that's essential for the learning experience, so to speak. So how do you do that on edX? Well, you can imagine it's not that hard to automate the creation of a cluster on OpenStack or on Amazon, right, or anything like that. Okay, so the problem is if by definition this is self-paced courses. If the student takes 3 months to finish the course, you're going to have a cluster that's been running for 3 months, and it's going to cost a lot of money. All right, so we needed a way out of this. And once again, Heat to the rescue. What you do is you create a heat stack for each student, and then you suspend it when he or she is not using it. All right, so no charge if it's not being used. So that works financially. Okay, it's a financial solution, whereas technically we knew we could do it. All right, so enter X blocks. The cool part, or the coolest part of edX, we think. X blocks are just Python. You can write anything you want in there, and edX the edX platform, the LMS or the CMS will run it for you. So that's awesome. We have a way now to automate the creation and suspicion of stacks. Okay. By the way, this is the X block I'm going to demonstrate in a while is up on GitHub as well. AGPL, open source, etc. Feel free to mess with it, criticize it, contribute, who knows. What is this then? This is how you would define or invoke this X block in a course, right? You specify where your cloud is, where your OpenStack cloud is, the authentication information. You upload the heat template to the data store of the course you're developing, and you refer to it here, hotlab YAML. You give it the SSH user that's going to connect to it, and basically that's it, right? The only other thing is that the heat template must output 2 things which the X block expects, and that's a public IP address of the stack that's being created for the student, of course, and a private key that needs to be generated by the heat template. So just 2 restraints on the heat template itself, okay? Now, here's where we became a little naughty. Since it's just Python, we access the data store directly from the X block. Right? The edX developers probably won't like this, to hear this, but this is what we came up with to, yeah, NetBat's shaking his head. Don't do that, man. It's part of the reason I'm saying this here. We want suggestions as to how to improve this, okay? And we also use the LMS's celery workers. We hijack those. In our defense, we sort of copied what the mentoring X block already does. It's now called, what's it called now? Problem Builder. Anyway, is Xavier around? Yeah, there's Xavier, yeah. Hey man, long time no see. So we do that. So we want a better way to do this, and we'd like suggestions later on, okay? Finally, connecting the browser to the lab environment. We have an awesome auto-suspending, auto-resuming environment. How does the student get to it? Okay? We came across something called GateOne, and it's an SSH, a terminal emulator written in Python and JavaScript that you can, and it has a nice API, so you can embed that into, for instance, the output of an X block. So that's exactly what we did, and that's what we used to connect the student's view of the LMS into the actual cluster. All right, and a couple more bells and whistles. We developed a little role to deploy this X block, and a role to deploy courses from Git, because we like Git, as does MIT, I learned just a while ago. Okay? Unfortunately, I won't have time for an actual demo because I have, what, 20 seconds, 10 seconds left? 5 minutes. Okay, you guys want to see this working? All right. Damn. All right, there we go. So this is that stack I was SSHing into. It's a regular edX stack with a Stanford theme and that X block I was telling you about. And I'm going to view course here. And we built a demo course on Ceph, just as is obvious by the name, for demonstration purposes. Where's my mouse? All right, so I'm going into the introduction. And what's happening now, right? I don't know if you can read this. It says, please wait until your environment is being fired up. What's happening behind the scenes is a heat stack described by the course author is being deployed to an OpenStack public cloud. By sheer coincidence, it's the same cloud that edX is running on, but it didn't have to be. It could be somewhere else entirely, okay? I had a stack already up there, and it's being resumed right now. If I'm lucky, the demo gods are going to be nice with me, and this is going to work, and in a minute, we're going to be SSH'd into the environment itself, okay? So let me check. Hey, it worked! There we are. Okay, so as you can see, the student didn't have to enter IP addresses, passwords, anything. This is all the course author's work. So the course author defines the heat template that fires up the environment. This particular environment has 4 VMs, I think. Okay, so they all talk to each other. You can fire up any kinds of services in there that work in a cloud. Okay, so that's it. Any questions? One. Good question. The credentials are, oh, I repeat the question, sorry. He asked, I think he asked, where are the credentials, the OpenStack credentials defined, right? So they're defined by the course author in the course where. Okay, so if you're using XML to write the course, it's in the XML. If you're using Studio to develop the course, it's when you instantiate the X block, the advanced module, I think it's called, it's in those options right there, right? You get to define options for an advanced module. You can do that from Studio, right? Does that answer your question? Okay. Anything else? Any other questions? Brendan.
Are you self-deploying and maintaining OpenStack deployments, or are you using external providers?
Good question. This edX cluster, he asked if I'm self-maintaining an OpenStack cloud just for this, or am I using an external provider? In this case, I'm using an external provider. Both edX itself is running on a public cloud that's not run by us, and the students' environments as well. They're running on a public cloud, no fancy stuff going on. It's even an old version of OpenStack these guys are running. I think it's Icehouse. You know, it's a year old, really old, right? In open source terms. Okay, cool. Another question.
So now you just found an environment that was already instantiated, right? So how much time do I have to wait if this is the first time I...
Excellent question. So I cheated, as I said, I cheated a little bit. Right? Repeating the question again, I always forget about that. So he asks, how much time does it take if the environment wasn't already fired up before? Okay, so in this case, as I said, I cheated. The environment was already there, just suspended. So what you saw is the time it takes to resume a student environment. So it was about, what, 10, 20 seconds, 30 seconds maybe. From scratch, it takes more like a minute or two, okay? Depending on the cloud and the number of VMs you have in your cluster, okay? So it's a function of the cloud you're using and the size of your heat template, okay? Any more questions? Excellent question. Does the cluster or does the student cluster suspend on the timeout or what? Okay, so what happens is if I close the browser window now, well, this thing's already on a dead man's timer or dead man's switch, right? If the browser window is open, a request is sent every, I think it's 2 minutes or a minute. And if that request is not sent for 2 minutes, then the stack is suspended. Okay, so that's the workaround with which we came up with. Okay, so I don't have any more time. That's it. Thank you very much. I hope you enjoyed it. All of this, by the way, sorry, is open source AGPL on GitHub. All right, on Hastexo's fork of edX configuration, and the Hastexo X block is also same deal. We'd love it for people to actually use this stuff, and we do intend to contribute as much as we can to edX itself. Okay, thank you.